Okay, 513. What we're dealing with is the number e. Sure doesn't look like a number. Well, pi is just like 3.14. E has its own little special value, and it's a special place in math. You don't hear about it very much, but you're about to. So, let's go through the checklist. First of all, recall that f of x equals a times b to the x is considered an exponential function. Here's an example. A is 2, b is 3. This is exponential growth because that's a number greater than 1. This is going to be a vertical stretch, factor of 2, but whatever. So the letter E is approximately 2.71. Just like pi, it goes on forever and ever. 2.71 is E. So when they give us something like this, f of x equals 3, there's our A, times b, which is 2.71 to the x power, is also an exponential function because this is a constant. Yeah, it's a decimal, but it's a constant, and that's going to be exponential growth. So, the rules for exponential growth / decay are the same. Now, this isn't decay, this is growth, because our b is greater than 1. So if we look at f of x equals e to the x, and I pick three little, not so random numbers, always go with the 0, because when you put e to anything to the 0 power is 1, so 1 times 1 is 1. That is a go-to point for exponential functions. So with that being said, type in -10 or put in -10. So that would be 1 times 2.71 to the -10 power. That is 1 over a huge number, which means like 1 over 10,000 is very small. So if I went way over here, it's going to be barely above the x-axis, and it comes in like this. Yes, I could type in -1, -2, -3, -4, but we're getting the general idea. So this is just very small positive number. 4, if I plugged it in there, it'd be right here. That's 3 basically to the 4th power times 1. This is a very large number. So if I went out 4, it'd go way up, so it looks just like all the other exponential growth graphs. And what you're going to be asked to do is remember your rules for transformations dealing with these exponential functions that deal with the letter E. Time to panic? Nope, because all these rules apply to every graph. So notice this is +2, which is just plus D. So I got to move this thing up 2. So kind of goes like that, to the best of your ability. I'm going to do the next one purple. I have to take the original, that's the red one, and reflect it over the x-axis. So that would be like, goes through 0, -1, and then it goes like that. Just spin it. The last one, let's go with green. What does this do? Well, it takes the original parent function right here, and it moves it right to. So I take this whole thing, I'm going to take that anchored spot, 1, 2, and then just try to duplicate the drawing. That's part 1 of this lesson. Okay, so we're just going to break away from the letter E. Here comes a nice little quick review of even. This is review simply because I've shown you one example. It doesn't mean you're good at it yet. So let's review that first. Now, how do I know this is an even degree? 2 plus 2 plus 2 is 6. That means it's going to follow the same rules as y equals x squared. So our parent function's like this, which tells me the extremities, no matter what happens in between here, they're going to be up to the left, up to the right, as long as a is 1, which it is. So the first thing I do, find my zeros. There's a 0, there's another 0, and then 1 is another 0. And because it's even, I know a couple things. It goes like this, just like a parabola. Those are the outer extremities. So this is, you know, like an Oreo cookie. These are the white cookie parts, or excuse me, the chocolate cookie wafers. And now we're going to put in the vanilla inside stuff. So, how do we do that? Well, first of all, because this is an even, that tells us it's going to go through this one. It tells us it's going to go through that one. So we know that it's going to go down, and then it's going to want to come back up, and then something's going to happen up in here, and so this has to come down, and we're going to figure out what happens in here by just putting in some points. So what we're going to do is, give me 1 second here. Okay, so, hold everything. Okay. Just a minute. Just a minute. All right, so here we go. Let's finish this. I just got my rules mixed up in my head, and I was going to erase it, redo the whole video, but I just want to show you how easy it is to make a mistake. I just got things messed up in my head, and you might too. So why don't I just own it? And remember that if these are even, that means they bounce off those zeros, so they don't go through. And I caught myself, but I just got myself confused. So it goes down here and it bounces off, so it might go up like this, it might be flat. This is just like the one we did in the first lesson of Unit 5. That means it gets here, and it gets to here, bounces, might go up like this, and then comes down here and then back up. So what we need to do is figure out what happens inside here. Well, this gets a little difficult, but if this is -3, which it is, and this is 0, the halfway point is -1.5, which is a little pain, but if we square -1.5, we get 2.25. If we go -1.5 plus 3, we get 1.5 squared is another 2.25. And then we go -1.5 minus 1 is -2.5 squared is 6.25. Now if I take my handy dandy calculator and I multiply all those values out, 2.25 times 2.25 times 6.25, I get 31.64. So, obviously I don't have room on this board, but it goes like this, goes way up, comes back down, and now I've got 0 and 1. I have to plug in, I have to let x equal 1/2 or 0.5, whatever's easier in your mind. I'll go with 0.5. Plug them in here. 0.5 times 0.5 is 2.5. Or excuse me, 1/2 times 1/2 is 0.25. And then 0.5 plus 3 is 3.5. I'll figure that out in a minute. Squared. And then 0.5 minus 1 is -1/2. Squared is another 0.25 or 1/4. So I'm going to hammer that out with my calculator. 3.5 squared times 0.25 times 0.25, I get 0.76. So if this is 1, goes here, it gets up about here, and there it is. Crazy looking graph, but that's an even degreed polynomial, because 2 is 6. So my extremities are going like this, and it bounces off all my zeros. The next thing we're going to do is talk about an odd degree polynomial, and I'll try to not screw up. All right, so now we're going to tackle, the author's kind of presenting your first odd degree polynomial in a little different fashion. But then I'm going to help you understand what's going on here. So, write an equation of an odd degree. Well, we'll talk about that in a minute. Polynomial function whose roots, that's just another word for zeros, at x equals -1, so here it comes, f of x equals, now if that's a root, then I'm going to think backwards and go, okay, like that. If that's a root, then I take the opposite of that, x minus 4, because if I said, hey, what's a 0? I'd say 4, so I'm thinking a little bit backwards. Triple root, what does that mean? It means x minus 2 cubed. Now, we'll talk about that quite a bit, and I'm thinking, okay, I'm done. Now here's the twist. This little guy is always haunting you. They don't give you the letter A as 1 all the time. It has been so far, but they're saying, okay, the y-intercept, in other words, if I was to graph this equation, they're telling me that it would go through, one point I know is 0, 6. Why are they giving me that clue? That's a way of their saying, hey, this time A doesn't equal 1. It's not that easy. So my x is 0, my y is 6. So I'm going to go 6 equals A, 0 plus 1, 0 minus 4, 0 minus 2 cubed, and see what happens. So this is 1 times -4 times -8. So that'd be 32. So 6 equals 32a, divide by 32, divide by 32. I'm going to go ahead and reduce that. 2 goes into both of those. And there's my a. So I take that and I put it right back here, 3/16. Now I have the actual equation. Now, I'm going to give you guys a little heads up right now and just tell you I'm not going to finish this, I'm just going to get your wheels turning. So if one of my zeros is -1 right here, another one's 4, 1, 2, 3, 4, another one's 2, I want you to know that this is a 1, this is a 1, this is a 3. These are all odd numbers. What that's telling me is, if I just remember y equals x cubed, and if my leading coefficient is positive, which it is, that looks like this. Why am I showing that to you? So that you know what the outer extremities do. So I go here, and I know it's going to go down from there, probably not that round, but then from here, it's going to go up. They mirror each other. The parent function, essentially, this is the parent function of all odd functions. But now I got to ask myself, okay, if these were even and they bounce, well, if they're odd, they must go through. And so this is the point. It goes through those zeros. Now, of course, that might be like this, and it might be like that. It might be like really flat, and then really deep. We don't know. And I'm not going to plug in these values because that's not really what the author wants us to do. But we could. We could plug in the halfway point, figure out exactly where it goes. We could plug in that value 3, figure out exactly how low it goes. But I just want to open your eyes up to the odd rules. If it's an odd power, then it goes through the zeros. If these are even numbers, then they would bounce. Keep that in mind. That's a big, big truth. Okay, I've only got a minute for these last 3, so I've done a lot of the work. I'm going to start with this easy one. Base, exponent, answer. Base, exponent, answer. Figure this out. 1/16. Done. Common bases, happy places. So I see 27 is 3 cubed. I see 9 is 3 squared. Power to a power, I multiply. I bring that up and it becomes negative. Now I'm going to multiply these powers. 3 to the -3 x plus 3 equals 3 to the 4x. I'm not going to finish it, but you set these equal to each other and solve for x. This one, 16 and 32, common bases 2's. Multiply that, 2 to the 4x minus 8 equals 2 to the 5th. Set that equal to that, solve for x, and you're done.